All right, so let's jump right in. For the last 20 years of his life, Stephen Hawking was absolutely obsessed with one single massive question. And what we're talking about today is the story of his final theory, really his last great intellectual adventure to figure out the origin of time itself. So, picture this, it's 1998. It's basically a job interview. This young physicist, Thomas Hertog, he walks into Stephen Hawking's office. And Hawking, speaking through that famous synthesizer, he doesn't ask about his GPA or his research papers. Nope, he asks this. And it's a question that sounds way more philosophical than scientific, right? It just completely sets the stage for everything to come. And just like that one question kicked off a 20-year collaboration. I mean, think about that. And Hawking and Hertog, they weren't just trying to solve some little physics problem. No, they were going after the biggest target of all, trying to figure out where the rules of the universe even came from. And their journey, well, it was about to rewrite the entire story of our cosmos. Okay, so let's get into what Hawking actually meant by that word designed. What was he getting at? Well, he was talking about this really weird thing that scientists had noticed, that the universe seems almost perfectly tailored for life to exist. They even have a name for it, a biophilic cosmos, basically a life-loving universe. And this is where it gets really mind-bending. I mean, look at how specific these conditions are. If you just nudged the strength of gravity a tiny bit, or messed with the mass of an electron, or heck, even changed the number of dimensions we live in, poof, that's it. Everything would vanish. No stars, no galaxies, not even atoms, and definitely no us. It's just wild. It's almost like the universe was expecting us. So you've got this huge puzzle, right? The fine-tuned universe. And for years, physicists basically had two main explanations. But for Hawking, neither of them felt right. They just seemed totally unsatisfying. One was kind of too neat, and the other was just pure chaos. So in one corner, you've got what's basically Einstein's dream, the idea that the laws of physics are these perfect, unchanging mathematical rules. They're set in stone. The universe just had to be this way. Then, in the other corner, you have the multiverse. This is the idea that there are an infinite number of universes out there, all with different rules, and we just got lucky. We happen to live in one of the very few where the cosmic lottery numbers came up right for life. And Hawking, well, he did not hold back. He apparently told Hertog in that very first meeting that the multiverse idea was outrageous. Just completely outrageous. For him, it just wasn't science. It was like giving up, a metaphysical fantasy that just neatly sidestepped the real question instead of even trying to answer it. Okay, so if the old ideas are off the table, what's left? Where do you go from there? Well, for Stephen Hawking, it meant he had to do something incredibly difficult. To find the answer, he had to admit that he himself had been wrong about one of his most famous ideas. I mean, just stop and think about the intellectual courage that takes for a second. To come out and say that your own book, A Brief History of Time, one of the most famous science books ever, was written from the wrong perspective. Wow. And this is the absolute key to their new theory. He realized that for centuries, we've been trying to describe the universe from this impossible God's eye view, as if we're angels looking in from the outside. But we're not. We're in the universe. We're part of the system. And that realization led them to a whole new way of thinking, something they called top-down cosmology. It kind of flips everything on its head. Instead of starting way back at the Big Bang, which we can't really know for sure, and trying to guess our way forward to today, you do the opposite. You start with what we can see and measure right now, and you work backwards. What we observe today actually shapes the story of the past. And this is where it gets really interesting, because this whole idea is ripped straight from the playbook of quantum mechanics. It's the idea that our existence, the very act of us being here to observe the universe, isn't just some random afterthought. No way. It has to be baked right into the theory itself. The observer isn't separate from the experiment. The observer helps create the outcome. So if you follow this new top-down way of thinking to its logical conclusion, well, you end up with their most radical, most game-changing idea. It's the idea that the laws of physics themselves, they're not fixed, they're not written in stone, they evolve. And this is a total 180 from the old way of thinking. I mean, it's a huge paradigm shift. We're going from this idea of a universe run by eternal, unchanging rules that existed before everything, to a universe where the rules themselves grew up with the universe. They were forged in the Big Bang, and they changed and settled into the form we see today. So how does that even work? How do laws of physics evolve? Well, it's an idea that sounds a lot like Darwin. Here's how it breaks down. First, you need variation. In the super hot, chaotic soup of the early universe, quantum mechanics was just throwing stuff at the wall, creating all sorts of different possible physical laws. Then you need selection. And what does the selecting? We do. Our observation of the universe, right here, right now, selects the one path through all that randomness that led to us. It freezes that history in place.
So what you end up with isn't one straight line of history. It's more like a massive, branching tree of possible physical laws. It's a beautiful analogy, right? Just like Darwin had his tree of life showing how species evolve and branch off, Hawking and Hertog are giving us a tree of physics, showing how the laws themselves could have evolved.
Now, this whole Darwinian physics idea, it has massive implications. It completely changes how we think about the Big Bang and even what time is. Okay, so here's the absolute punchline. There were no laws of physics sitting around in the dark waiting for the Big Bang to happen. The Big Bang wasn't just some explosion in space. It was the birth of space, the birth of time, and the birth of the laws themselves. Everything popped into existence all at once. In this new picture, the Big Bang becomes something called an epistemic horizon. That's a fancy way of saying it's the edge of what we can ever know. It's like a wall. As you try to look back towards it, the laws of physics get simpler and simpler until they just fizzle out. Causality, time, it all dissolves. It's the point where the universe literally runs out of information to give us. Now, I know what some of you might be thinking. This sounds cool, but it's just philosophy, right? Well, that's the amazing part. It's not. Hawking's final theory is more than just a nice idea. It actually makes predictions. It's real science. And that means one day, we might actually be able to test it. You can really see this as the next chapter in a story that's been unfolding for over 100 years. It started with Einstein and his groundbreaking theories. Then Lemaitre used those ideas to figure out the Big Bang was a thing. And now Hawking and Hertog are handing us the next piece of the puzzle, a way to actually search for the fossilized evidence of that very early evolutionary phase of the universe. So how in the world would we test it? With gravitational waves. See, light can't get through the super dense fog of the early universe, but gravitational waves, these tiny ripples in space-time itself, they can. They've been traveling towards us since the very beginning. And we're building these incredible new experiments, things like the LISA satellites, specifically to listen for these ancient whispers from the dawn of time. We might actually be able to hear the fossils of those first branches on the tree of physics. And, there's a really beautiful, kind of poetic end to this part of the story. After Stephen Hawking passed away, his ashes were buried in Westminster Abbey. And get this, his final resting place is right between Isaac Newton, the man who gave us the idea of fixed, unchanging laws of physics, and Charles Darwin, the father of evolution. It's just perfect. And that, really, is Hawking's final incredible legacy. It's a whole new story for our universe. Not a cold, predictable story based on math, but a dynamic one of evolution, of emergence. And it leaves us with one last massive question to chew on. If the very laws of nature evolved with our universe and were selected in a way by our own existence, what does that really say about our place in all of this?